So good afternoon. You are welcome to this online facilitation for Physics 313 for the second stream in the year 2022. I'm going to be your instructor for the next 8 weeks. So my name is Dr. Adetunji. I work at Best University of Technology, Ota, as a senior lecturer in the Department of Physical Sciences. So for this course, I'm going to be interacting with you for the next 8 weeks, where we are expected to cover some certain topics, starting with introduction to the course, which we are going to do today. So thereafter, we start discussion fully on functions of complex variable. I sent 2 mails during the weeks where I've sent the course plan and also the course lectures materials. I hope each and every one of you received the mails. So also, every week, I'll be sending emails to you, giving you instructions and guides on what you're expected to do before our next class. And our classes have been slated for Thursday between 4 and 5. So please make sure you stick to this time and join us periodically. If you miss the class, don't be panicked. Each classes will be recorded and the videos and the audios will be uploaded and the links will be shared for you to be able to have a recast of what we have done during the week. So as I've said, the first week is just a kind of introduction and a guide to what you're expected in this course. So the second week, we start discussion on functions on complex variable. In this, I'll be introducing what complex variable are and their properties, and also their main functions or their main uses, and how to solve simple examples using most of these properties. Some of the properties include addition, subtraction, divisions, and I will try as much as possible, to give you links between the theory and the applications, which I believe it will guide in understanding the concept of functions of variable. In the third week of our facilitation, we shall be looking at what we call Cauchy sequence. So I'll be discussing with you what Cauchy sequence are, how do we use them, and what are they used for, and how do we solve basic problems using the theory and the laws associated with Cauchy sequence. In the fourth week, which is the middle of the facilitation, we shall be discussing geometric interpretation of complex function. In the second week, we have introduced what complex functions are. Then now let's now look at them in geometrical form. The one we are going to discuss in the second week is mainly in the polar coordinates. But when we now come to geometric interpretation, now we now see the application in cylindrical coordinates and also in polar coordinate form. So in the fifth week, we shall be looking at analytic function. So what are analytic functions? What are they used for? How do they use them? Why do we need to learn them? These are things we are going to be looking at. And also, we try to solve some basic examples using these laws and their rules. While in the sixth week, we shall be looking at complex integral. There are some integral functions in physics and in mathematics that requires some ideas, which using this concept or understanding this concept, it will be very, very easy for us to solve some of these problems. For example, when you are solving a problem in electromagnetic theory, in which you are looking at the movement of charge in a loop, these are basic mathematics ideas that you need to understand before you can solve some of these complex problems. While in the seventh week, we shall be looking at residual theory. What are residual theory? Why do we need to learn them as a physicist? and what are their applications. These are the major things we are going to be looking into, trying to analyze and try to give you ideas on how to apply most of these concepts. So basically that is just a rundown or a summary of what you are expected to do in this course for the next 8 weeks. So if you have any problem or any questions, you can reach me through my mail or you can send WhatsApp message to me. So feel free to interact with me when you have issue as regards this course. Don't be panic, because interactions and exchanging of ideas gives one a better understanding of the concept of the course. So let's start the course straight by looking at what are complex variables. So functions of complex variable. Complex variable, they are variables that can take on values of complex number. For example, z, which can take on a and b as a complex number in terms of the form z is equals to a plus ib. So z is a complex variable, a and b are real numbers. So when you come across an expression like this, z is equals to a plus ib, you will see that there are three variables there. You have z, a, and b. But there's another constant introduced called I. So once you see that, the equations is technically telling you that this is an expression of a complex variable, which involve z, a plus ib. In some textbook, you will see it as z is equal to x plus iy. So x and y are real numbers. In this case also, a and b are more or less like a replicate of x and y, which is the same thing as a real numbers. So y z in this case is just like the father that has the child that has two children, a and b. So z in this case is referred to as a complex variable. Now, complex number. There is no how you talk about complex variable without trying to understand what complex number is, because they are like similar twins. You cannot separate them. They work together. So a complex number is a number of the form a plus ib or bi, where a and b are real numbers, and I is an indeterminate satisfying I square is equals to -1. Please take note of this. When you see I, when you square I, you get a negative value, which is -1. So automatically, I stand for the square root of -1. And you know, in mathematics, it's not easy to find the square root of a negative number. So that makes the expression a complex equations to solve. So therefore, we can say that the a part in this equation, z is equal to a plus ib, is real, that is normally represented as re bracket of z, and b is im, meaning imaginary. Re mean real, im mean imaginary. So when you see imaginary, that tells you that that particular aspect of that complex variable is one that is carrying the complex number I. So this implies that there are two parts in the equation of the form z is equal to a plus ib, where re is the real part and iz is the imaginary part. Now let's look at, if you look at this table, you know, this table, from your own basic understandings of graphical interpretation, you know, you can say this is y and this is x-axis. But now when you take this into a complex variable analysis, so along y-axis is where you have the imaginary, and what you have there is b, and along x is where you have the real, and what you have there is a. So now let's look at the properties of complex number now. One of the important properties of complex number that is of importance to us when we are doing analysis of complex variable is equality. When it says something is equal, meaning that no matter how you add, you subtract, you divide, you do this, they must produce the same result. So we say when a or b are real numbers, and you now say A plus IB is equals to 0. This implies that A is equals to 0 and B is equals to what? 0. When A, B, C, and D are real numbers and A plus IB is equals to C plus ID, then we can say that A is equals to C and B is equals to D. What happened here is just a kind of comparison of variables. If you say the first equation is A plus IB and the second equation is C plus ID, if the law of equality is at stake, then you can say that the first one is equals to this, the first equation is equal to the second equation. And if that happens, you look at the one that has the same properties. You see that when you have A plus IB is equals to C plus ID, it is only A and C that stand as an entity. But IB and ID, they also have something in common. So we can technically explain this that A is equals to C because of the law of equality, and IB is equals to ID because of what? The law of equality. So technically speaking, A is equals to C and B is equals to what? D. Also, for any three, the set complex numbers, let's say Z1, Z2, and Z3, that is, when you have three sets of complex number, they must satisfy a three main laws in algebra. The first one is commutative, and the second one is associative, and the third one is what we call distributive laws. So the sum of two conjugate complex number is real. Do you understand that? When you say the sum of two conjugate complex number is real, do you know what that means? I will show you an example in a few minutes time so you understand this aspect very well. Another properties is the product of two conjugate complex number is real. Firstly, we said when you had two conjugate complex number together, it will give you a real number. Now, you now say again that when you have the product that is the multiplication of two conjugate complex number, you also have a real number. Okay, now, when the sum of two complex number is real and the product of the two complex number is also real, then the complex number are conjugates to each other. If you look at this expression now, we have the absolute Z1 plus Z2 less than or equal to single absolute Z1 plus single absolute Z2. So for two complex numbers, Z1 and Z2, you can say that a commutative law is equals to Z1 plus Z2 is equal to Z2 plus Z1. As if when you have Z1 to equals to this and Z2 equals to this, automatically when you add them together, when you add Z1 plus Z2, the result you are going to obtain is going to be the same thing as adding Z2 to Z1. And that's what we call the law of commutative, that is of addition. We also have law of commutative of multiplication. If you multiply Z1 with Z2, the result you are going to obtain is going to be the same result as multiplying Z2 with Z1. Likewise, when you have associative law, let's say that we're having three complex number now, Z1, Z2, and Z3. They want to test if these three complex numbers satisfy what we call associative law. How do you go about it? Pick the first two, Z1 plus Z2, then add the result to Z3. Automatically, you must have the same result as adding Z2 plus Z1 and adding the result to Z1. If this happens, this is what we call associative law of addition. The same thing, if you multiply Z1 with Z2 and you now multiply the result with Z3, it's more or less like multiplying Z2 with Z3 and multiply the result with Z1. This is what we call associative law for multiplication. The third law, which is distributive law. If you have Z1, then you now add Z2 plus Z3 and multiply by Z1. The result of this is more or less like multiplying Z1 with Z2, have the result, then multiply Z1 with Z3, have the result, then add the two together, you get the same result as adding Z2 plus Z3 and multiplying by Z1. So these are the basic law that govern the complex variable analysis. So the commutative law, where we have addition and multiplication, the associative law, where we have addition and also multiplication, and the last one, which is distributive law. So you can look at some examples. Say, given that Z1 is equal to 2 minus 4i, and Z2 is equal to 4 plus 6i, and Z3 is equal to 5 minus 2i, show that Z1 So that one, Z1 plus Z2 is equal to Z2 plus Z1. That is, you have to establish that this expression satisfy commutative law of addition. And also, the second question there, you have to establish that this complex number given to you satisfy commutative law of multiplication. And the third one also is trying to test if the law actually satisfies associative law of addition and also associative law of multiplication. So let's look at some of the solution. Say, okay, Z1 is equal to 2 minus 4i, and Z2 is this, and Z3 is this. So the first thing is Z1 plus Z2. So if you had 2 minus 4i with 4 plus 6i, corresponding one, 2 plus 4, that will give you what? 6. And minus 4i plus 6i, that give you plus 2i. So if you do the same thing for Z2 and Z1, you have 4 plus 6i plus 2 minus 4i. 4 plus 2 will give you 6, plus 6i minus 4i will give you 2i. You now see that the same result you have with Z1 plus Z2 is the same result you obtain from Z2 plus Z1. So this satisfies commutative law of addition. Any question? Any questions on this? Okay. If there is no question, so I will expect you to also try to lay your hands on the second problem, try to solve them, and also the third one, using those ideas I've stated earlier on. So if you can do this, at least you are getting familiar with the properties and the rules of complex number. So since today is just like an introduction to the course, so I will expect you to take your time to go through some of what I've explained to you and what I've just introduced to you. So in the next class, we take our time to fully analyze and demystify the concept of function of complex variable. So thank you for coming. So see you next week. Have a nice and lovely weekend. Is anybody with question? Okay, there's no question. See you next week.